Hello, in this lecture we will find out the radius of the circle. In the drawing we have a circle. Inside the circle we have chord AC that is equal to square root of 2 units in its length. Chord DB equals to 2 units. And this angle BED equals to 45 degrees in its size. Our mission is to find out the radius of this circle. So we will use two rules in order to solve the question. The first rule is that the central angle is twice as big as the peripheral angle resting on the same chord. Repeat again. The central angle is twice as big as the peripheral angle resting on the same chord. So this is angle AOB. It is defined as a peripheral angle. It is equal to alpha and it rests on chord AB. Angle AOB is a central angle and it rests on the same chord AB. So because of the fact that the peripheral angle equals to alpha, the central angle that rests on the same chord must be equal to 2 alpha. Okay, so the central angle is twice as big as the peripheral angle that rests on the same chord. So if the peripheral angle equals to alpha, then the central angle equals to 2 alpha. Why? Because of the fact that those two angles are resting on the same chord AB. And we have the second rule, that is the law of cosines. The law of cosines is true in any triangle. So this triangle ABC could be any triangle. The length of side AB equals to A units. Side AC equals to B units in its length. Side BC equals to C units. And this angle BAC equals to theta. Then according to the law of cosines, the following equation is true. That C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. And from this equation, it is very easy to arrive to this equation, that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times AB. Okay? In the next step, we define the center of this circle, this point, as point O, and then we join points O and B, O and D, O and A, and O and C by a straight line. Okay. So those 4 line segments OB, OD, OA, and OC, they are all the radii of this circle. Why? Because of the fact that they start from the center of this circle, that is to say from point O, and ends at points B, D, A, and C. All those 4 points are located on the circle itself. And any line segment that starts from the center of a circle and ends at any point on the circle itself, it is defined as a radius. Therefore, all those 4 line segments are the radii of this circle. So we define the radius of this circle as r, and therefore OB equals to r, OB equals to r, OA equals to r, and finally OC is also equals to r. This is angle BAD, the peripheral angle BAD that rests on chord BD. So we define this angle as x over 2. So the peripheral angle BAD that rests on chord BD equals to x over 2 degrees in its size. Therefore, the central angle DOB that rests on the same chord DB must be equal to twice as the peripheral angle x over 2, that is to say it is equal to x. According to the rule that I mentioned in the beginning of the lecture. Likewise, we'll define peripheral angle ADC. This peripheral angle is y over 2 degrees. Therefore, so the peripheral angle ADC rests on chord AC, and it is equal to y over 2 degrees in its size. Therefore, the central angle AOC that rests on the same chord AC must be equal to y over 2 times 2 y. That is to say, to y degrees in its size. In the next step, we'll focus on the straight line AB. This straight line AB at point E. And which angles we have at the upper side of the straight line AB at point E? We have this angle that is equal to 45 degrees plus the missing angle. In total, they must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So therefore, the missing angle must be equal to 135 degrees. Why? Because 135 degrees plus 45 degrees equals to 180 degrees, exactly according to rule number 1 that I mentioned. Okay. In the next step, we'll focus on the green triangle AD. We know that the sum of the angles of any triangle is equal to 180 degrees. Therefore, the sum of the angles inside the green triangle AD must be equal to 180 degrees. So which angles we have inside triangle AD? The green triangle AD. We have this angle that is x over 2, this angle is y over 2, and this angle that is 135 degrees. In total, they must be equal to 180 degrees according to the rule that I mentioned. So x over 2 plus y over 2 plus 135 degrees, in total, they must be equal to 180 degrees. Repeat again, the sum of the angles in the green triangle AED must be equal to 180 degrees. Okay, so we subtract 135 degrees from this equation, and we get that x over 2 plus y over 2 equals to 180 degrees minus 135 degrees. It is equal to 45 degrees. x over 2 plus y over 2 equals to 45 degrees. We'll multiply this equation by 2. X over 2 times 2 is x, y over 2 times 2 is y, and 45 degrees times 2 is 90 degrees. So x plus y equals to 90 degrees. That's what we got here. We'll subtract x from this equation, and we get that y equals to 90 degrees minus x. Okay. In the next step, we'll implement the law of cosines on the pink triangle, triangle BOD, this pink triangle. So, in the pink triangle, triangle BOD, according to the law of cosines, we get that cosine x equals to r square plus r square minus 2 squared, that is 4, over 2 times r times r. Okay. This equation number 1, is the implementation of the law of cosines on the pink triangle, triangle BOD. Okay, so we found out that according to this equation number 1, cosine x equals to r square plus r square is 2r square minus 4 over 2 times r is 2r square. So cosine x equals to, we'll split this expression into 2 parts. The first part will be 2r square over 2r square, and the second part will be minus 4 over 2r square. So cosine x, according to equation number 1, equals to 2r square over 2r square is 1, and here we have minus 4 over 2 is minus 2, so in the numerator we have minus 2, in the denominator we have r square. So in conclusion, we found out that according to equation number 1, cosine x equals to 1 minus 2 over r squared. In the next, we will multiply this expression by 1, so it is minus 2 times 1. In the next step, we implement the law of cosines in the yellow triangle, triangle AOC. In the yellow triangle, triangle AOC, according to the law of cosines, you get that cosine y equals to r squared plus r squared minus square root of 2 squared. Square root of 2 squared is 2 over 2 times r. Equation number 2 is the implementation of the law of cosines on the yellow triangle ACO. So according to equation number 2, we found out that cosine y equals to r squared plus r squared is 2r squared minus 2 over 2 times r is 2r squared. In the next step, we'll split this expression into 2 parts. Okay. And we get that according to equation number 2, cosine y equals to 2r squared, or 2r squared is the first part, and the second part is minus 2 over 2r squared. So actually we found out that according to equation number 2, cosine y equals to 2r squared over 2r squared is 1 minus, here we have minus 2 over minus 2 is minus 1. So in the numerator we have minus 1. In the denominator we have r squared. So actually we found out that according to equation number 2, cosine y equals to 1 minus 1 over r squared. We already found out that y equals to 90 degrees minus x, therefore we substitute y in this equation number 2 by 90 degrees minus x, and we get that cosine y equals to cosine 90 degrees minus x, and cosine 90 degrees minus x, it is equal to sinus x, of course. So if we're going to found out that cosine y equals to sinus x. Cosine y equals to sinus x. Therefore, you can substitute cosine y in this equation number 2, by sinus x. We'll do it now, and we'll get that cosine y according to equation number 2 is sinus x. And it is equal to 1 minus 1 over r squared. And according to equation number 2, we found out that, according to equation number 1, we already found out that cosine x equals to 1 minus 2 times 1 over r squared. The next step, we define 1 over r square as t equals to 1 over r square, and we substitute 1 over r square on those two equations, equation number 1 and equation number 2, by t. So according to equation number 1, cosine x equals to 1 minus 2 times 1 over r square, so, and 1 over r square equals to t according to our definition, so we substitute it by t. In conclusion, we found out that according to equation number 1, cosine x equals to 1 minus 2t. And according to equation number 2, we found out that sinus x equals to 1 minus 1 over r square. 1 over r square is t, so we substitute 1 over r square in this equation number 2 by t. And in conclusion, you will get that according to equation number 2, sinus x equals to 1 minus t. So we have two expressions for sinus x and cosine x. In the next step, we'll use the trigonometric identity that states that sinus square x plus cosine square x equals to 1. We implement this trigonometric identity on those two expressions for sinus x and cosine x. This will be equation number 3. So, we have this trigonometric identity. According to this trigonometric identity, sinus square x sinus x equals to 1 minus t, therefore sinus square x will be equal to 1 minus t square plus cosine square x. Cosine x equals to 1 minus 2t, therefore cosine square x equals to 1 minus 2t square equals to 1. We'll open the brackets on this side of equation number 3, and we'll get that according to this equation, equation number 3, one minus t square equals to 1 squared, that is 1, plus t square minus 2t. We'll open the brackets of this expression also, 1 minus 2t square, 1 minus 2t square equals to 1 squared, that is 1, plus 2t squared, that is 4t square, minus 2 times 2t is minus 4t, and it is equal to 1. So here we have t square plus 4t square equals to 5t square. Here minus 2t minus 4t is minus 6t. And finally, we have 1 on both sides of the equation, so 1 will get cancelled, and we're left only with this one, so it is plus 1, that is equal to 0. Okay, we found out that according to equation number 3, 5t squared minus 6t plus 1 equals to 0. In the next step, we will substitute minus 6t by minus 5t minus 1t, and we'll get that t squared and minus 6t is minus 5t minus 1t plus 1 equals to 0. In the next step, we take 5t as a common factor from those two expressions. So 5t was taken out as a second factor. So what is left from 5t squared after we took from it 5t as a second factor? What is left is actually t. And what is left from minus 5t after we took from it 5t as a second factor? What is left is it is actually minus 1. The next step, we take out the common factor, we take out minus 1 as a common factor from those two expressions. We get that minus 1 was taken out as a common factor. So what is left from minus t after we took from it minus 1 as a common factor? What is left is actually t. And what is left from plus 1 after we took from it minus 1 as a common factor? What is left is actually minus 1. Why? Because minus times minus is plus. So we plus 1. So it is equal to 0. In the next step, we take out t minus 1 as a common factor from those two expressions. So what is left from 5t times t minus 1 after we took from it t minus 1 as a common factor? What is left is actually 5t. And what is left from minus t minus 1 after we took from it t minus 1 as a common factor? What is left is actually minus 1. And it must be equal to 0. So here we will have two solutions that are possible for the value of t, or for the solution of this equation number 3. Either t minus 1 equals to 0, or 5t minus 1 equals to 0. So if t minus 1 equals to 0, it means that t equals to 1. And we have, according to our definition, t equals to 1 over r squared. So we substitute t in this equation by 1 over r squared, and we get that 1 over r squared equals to 1. The next step, we multiply this equation by r squared, and we get that r squared equals to 1. Here we'll take a root out of this equation, and we'll get that r equals to plus minus the square root of 1. The negative square root of 1 is minus 1, and the positive square root of 1 is 1. So r equals to 1, or r equals to minus 1. But because of the fact that r is a length, and the length must be a positive number, the solution that r equals to minus 1, that is a negative number, is not correct, is not possible. We cancel this solution, and we're left only with the solution that r equals to 1. Okay. So the other possibility is that 5t minus 1 equals to 0. We'll add 1 to this equation, and we'll get that 5t equals to 1. We divide this equation by 5, and we get that t equals to 1/5. According to our definition, t equals to 1 over r squared, so we substitute t in this equation by 1 over r squared. So here we have t is 1 over r squared, that is equal to 1/5. Okay, here we'll cross multiply this equation, and we get that r squared equals to 5. In the next step, we take a root out of this equation, and we will get that r equals to plus minus the square root of 5. So either r equals to the negative square root of 5, or r equals to the positive square root of 5. Again, because of the fact that R is a length, and a length must be a positive number, the possibility that R equals to 1 square to the negative square root of 5, that is a negative number, is not correct. We'll cancel the solution. So instead, we actually left with two solutions that are possible to solve equation number 3, for the radius of the circle. Either the radius of the circle will be equal to 1 unit, or the radius of the circle could be equal also to the square root of 5 units. In the next step, we'll focus on the original drawing. This original drawing, line segment or chord DB equals to 2 units in its length. It's very easy to see from the drawing that chord DB doesn't pass for point O, that is the center of the circle. Any chord that doesn't pass for the center of the circle is not the diameter of the circle. Why? Because all the diameters of a circle must pass for point O, that is the center of the circle. And because of the fact that chord DB doesn't pass for point O, that is the center of the circle, chord DB is not the diameter of the circle. And we also know that the diameter of any circle is the longest chord in the circle. So the diameter 2R must be greater than chord DB, that is not the diameter. So I write it down. The diameter 2R must be greater than DB, that is not the diameter. I repeat again. The diameter 2R must be greater than DB, that is not the diameter. According to what is given as the equation, DB equals to 2, therefore we substitute DB in this inequality by 2, and we get that 2R is greater than DB, but DB is 2. So 2R is greater than 2, we'll divide this equation by 2, and we finally will get that R is greater than 1. So if R is greater than 1, then R cannot be equal to 1. So the solution that R equals to 1 is not correct. We cancel the solution. So we left only with the other solution, that R equals to square root of 5. In terms of numbers, it is equal to 2.236 units. So we finished to answer on this question. In the next step, we will summarize the lecture. I repeat again here that the radius of this circle R equals to either square root of 5 units, or in terms of numbers, it is equal to 2.236 units. So, in this lecture, we found out the radius of this circle. It's given us the question that chord DB equals to 2 units in its length, chord AC equals to square root of 2 units in its length. In this angle BED equals to 45 degrees in its size. Again, our mission is to find out the radius of this circle. Actually, we used two rules in order to solve the question. The first rule is that the central angle is twice as big as the peripheral angle resting on the same chord. So here, the peripheral angle ACB equals to alpha, and it rests on chord AB. The central angle AOB rests on the same chord called AB, therefore it must be twice as big as the peripheral angle ACB. And because of the fact that the peripheral angle ACB equals to alpha, then the central angle AOB must be equal to 2 alpha. Okay, so the central angle is twice as big as the peripheral angle that rests on the same chord. Then we have rule number 2, that is the law of cosines. The law of cosines is true in any triangle, so this triangle ABC could be any triangle. The left of side AB is A, the left of side AC is B, and the left of side BC is C. This angle BAC equals to theta. So, according to the law of cosines, the following equation is true, that C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. And from this equation, it is very easy to arrive to this equation, that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B again. Cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. So first of all, we defined the center of this circle, this point as O, and then we joined points O and B, O and D, O and A, and O and C by a straight line. Those 4 line segments, they are the radii of this circle. Why? Because they start from the center of this circle, that is to say from point O, and then since points B, D, A, and C, all those 4 points are located on the circle itself. And this is exactly the definition of a radius. Any line segment that starts from the center of the circle and ends at any point on the circle itself, it is the radius. So OB equals to OD equals to OA equals to OC equals to R, because R, according to we defined the radius of this circle as R. Therefore, all those 4 line segments are the radii of this circle. That is to say they are equal to R. Okay. Then we have this peripheral angle BAD. It is equal to x over 2 according to our definition. This peripheral angle BAD rests on chord DB, and it is equal to x over 2. Therefore, the central angle BOD that rests on the same chord DB, must be equal to x. Then we have the central angle ADC that rests on chord AC, and it is equal to y over 2. Therefore, the central angle that rests on the same chord AC must be equal to y. Then we have the straight line AB. We focused on the straight line AB at point E. This angle, which angles we have on the upper side of the straight line AB at point E, we have this angle that is equal to 45 degrees. So the missing angle must be equal to 135 degrees. According to rule, the sum of the angles on the upper side of the straight line must be equal to 180 degrees. So 45 degrees plus 135 degrees equals to 180 degrees, exactly according to the rule that I mentioned, rule number 1. Okay, then we focused on the green triangle AD. On the green triangle AD must be the sum of the angles is 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So which angles we have inside triangle AD, the green triangle? We have this angle x over 2 plus y over 2 plus 135 degrees. It must be equal to 180 degrees, according to the rule that I mentioned. I repeat again, x over 2 plus y over 2 plus 135 degrees must be equal to 180 degrees. Here we subtracted 135 degrees from this equation and found out that x over 2 plus y over 2 equals to 180 degrees minus 135 degrees is 45 degrees. Then we multiplied this equation by 2, and we got that x over 2 times 2 is x, y over 2 times 2 is y, and 45 degrees times 2 is 90 degrees. So in conclusion, we found out that x plus y equals to 90 degrees. Then we subtracted x from this equation and found out finally that y equals to 90 degrees minus x. Then we implemented the law of cosines on the pink triangle, triangle DOB. According to the law of cosines on the pink triangle, triangle DOB, cosine x equals to r squared plus r squared minus 2 squared, that is 4, over 2 times r times r. I repeat again, in the pink triangle DOB, cosine x equals to r squared plus r squared minus 2 squared, that is 4, over 2 times r times r. So cosine x equals to r squared plus r squared is 2r squared minus 4, and 2 times r is 2r squared. So here, so cosine x equals to, we split this expression into two parts. The first part is 2r squared over 2r squared, and the second part is minus 4 over 2r squared. So cosine x equals to 2r squared over 2r squared is 1, and minus 4 over 2 is minus 2, so in the numerator we have minus 2, in the denominator we left only with r squared. We multiplied this expression by 1, and we got this expression. In the next step, we implemented the law of cosines in the yellow triangle, triangle AOC. According to the law of cosines in the yellow triangle AOC, cosine y equals to r squared plus r squared minus square root of 2 squared. Square root of 2 squared is 2, so it is r squared plus r squared minus 2 over 2 times r times r. Repeat again, the yellow triangle AOC. According to the law of cosines, cosine y equals to r squared plus r squared minus 2 over 2 times 2 over 2 times r times r. So cosine y equals to r squared plus r squared is 2r squared minus 2 over 2 times r is 2r squared. Then we split this expression into two parts. The first part is 2r squared over 2r squared, and the second part is minus 2 over 2r squared. So cosine y equals to 2r squared over 2r squared minus 2 over 2r squared. 2r squared over 2r squared is 1. Minus 2 over 2 is minus 1. So in the numerator we have minus 1, and the denominator we left only with r squared. So according to equation number 2, cosine y equals to 1 minus 1 over r squared. Okay. And it is given us the question, we have already found out that cosine, that y equals to 90 degrees minus x, therefore we substitute y in equation number 2 by 90 degrees minus x. So cosine y equals to cosine 90 degrees minus x, because y equals to 90 degrees minus x. And cosine 90 degrees minus x, it is equal to sinus x. In conclusion, we found out that cosine y equals to sinus x. Again, cosine y equals to sinus x. Therefore, we substitute cosine y in equation number 2 by sinus x, and found out that sinus x equals to 1 minus 1 over r squared. Again, sinus x equals to 1 minus 1 over r squared, while according to equation number 1, we already found out that cosine x equals to 1 minus 2 times r over r squared. Then we define 1 over r squared as t, and we substitute 1 over r squared in both equations by t. So in equation number 1, we have cosine x equals to 1 minus 2 times 1 over r square, and 1 over r square is t, therefore substitute it by t, and we got that cosine x equals to 1 minus 2t. Then we have in equation number 2, sinus x equals to 1 minus 1 over r square, but 1 over r square equals to t, so we substituted it by t and found out that sinus x equals to 1 minus t according to equation number 2, and according to equation number 1 we have found out that cosine x equals to 1 minus 2t. So we have here expressions for cosine x and sinus x. And we use the trigonometric identity that states that sinus square x plus cosine square x equals to 1. So according to this trigonometric identity, here if sinus x equals to 1 minus t, then it means that sinus square x equals to 1 minus 2 minus t square plus cosine square x. Plus, so if cosine x equals to 1 minus 2t, it means that cosine square x equals to 1 minus 2t. So cosine square x is 1 minus 2t square, that is equal to 1 according to this trigonometric identity. Then we open the brackets on this side of equation number 3 and found out that 1 minus t square equals to 1 square plus t square minus 2t plus 1 minus 2t square equals to 1 square, that is 1, plus 2t square plus 2t square is 4t square, minus 2 times 2t is minus 4t, that is equal to 1. T square plus 4t square is 5t square, minus 2t minus 4t is minus 6t. We have 1 on both sides of the equation. Here, so 1 will get cancelled, so we left only with this one, so it is plus 1, that is equal to 0. So according to equation number 3, 5t squared minus 6t plus 1 equals to 0. Then we substitute minus 6t by minus 5t minus 1t. We got that that 5t squared minus 6t is minus 5t minus 1t plus 1 equals to 0. Then we took 5t as a common factor from the two expressions in the yellow column. So inside the brackets we left 5t minus 1. Then we took out minus 1 as a common factor from those two expressions in the green color. So inside the brackets we left 5t minus 1, that is equal to 0. Then we took out t minus 1 as a common factor from those two expressions. Therefore inside the brackets we left only with 5t minus 1 equals to 0. So here we have two solutions for the value of t, or for the solution of equation number 3. Either t minus 1 equals to 0 or 5t minus 1 equals to 0. If t minus 1 equals to 0, it means that t equals to 1. But according to our definition, t equals to 1 over r squared, so we can substitute t in this equation by 1 over r squared. We did it, and we got that t is 1 over r squared, that is equal to 1. Here we multiply this equation by r squared, and finally we found out that r squared equals to 1. We took a root out of this equation, and we found out that r equals to plus minus the square root of 1. The negative square root of 1 is minus 1, and the positive square root of 1 is plus 1. Because of the fact that r is a length, and the length must be a positive number, the solution that r equals to minus 1, that is a negative number, is not possible. We cancel this solution, and we left only with the solution that r equals to 1. Then we have the second possibility that 5t minus 1 equals to 0. We added 1 to this equation and found out that 5t equals to 1. Then we divided this equation by 5, and we got that t equals to 1/5. According to our definition, t equals to 1 over r squared, so we substitute t by 1 over r squared in this equation, and we got that t is 1 over r squared equals to 1/5. we cross multiply this equation and found out that r squared equals to 5. We took a root out of this equation and found out that r equals to plus minus the square root of 5. R cannot be equal to the negative square root of 5 because r is a length and the length must be a positive number and it cannot be equal to this minus square root of 5, that is a negative number, so we cancel the solution and we left only with the solution that r equals to the positive square root of 5, or we have also the other possibility that r equals to 1. Then we focused on our original drawing. In our original drawing we have code dB that is equal to 2 units. It is very easy to see from the drawing that code dB doesn't pass through point O, that is the center of the circle. Therefore, code dB cannot be the diameter of the circle. Why? Because only chords that pass through the center of the circle, that is to say from point O, can be the diameter of the circle. Code dB doesn't pass through the point O, therefore it is not the diameter of the circle. So code dB is not the diameter of the circle. And we have also the rule that the diameter of any circle is the longest chord of the circle. So the diameter 2r of this circle must be greater than chord dB, that is not the diameter. Here, the diameter 2r must be greater than dB, that is not the diameter, but dB equals to 2 units, according to what is given as the equation. So we substitute dB by 2 in this inequality and found out that 2r equals to, and 2r is greater than dB, that is 2. We divided this inequality by 2 and finally found out that r is greater than 1. If r is greater than 1, r cannot be equal to 1. So we cancel this solution that r equals to 1 and we left only with the second solution that is possible for r, that r equals to the positive square root of 5, or in terms of numbers it is equal to 2.236 units. Okay, so the answer to this question is that r, the radius of this circle, equals to either square root of 5 units, or in terms of numbers it is equal to 2.236 units. Okay, thank you very much.